This is pre-algebra lesson 5-8, solving equations by multiplying fractions. We've already learned how to undo multiplication and division, multiplying and dividing each side of an equation by the same number. You can also multiply each side of an equation by the same fraction to undo multiplication. Simply, to undo multiplication, you multiply by the reciprocal. For example, if I have this first equation here, 7y equals 1/3. I could divide by 7, but dividing by 7 is the same as multiplying by 1/7. If I look at this, if I have 7y here, if I divided by 7, I'd end up with y. If I have 7y over 1 and I multiply it by 1/7, I still end up with y. So dividing by a number is the same as multiplying by its reciprocal, which is how you solve equations when you're dealing with multiplication. So 7y equals 1/3. I'm going to multiply both sides of this equation by 1/7. This 7 cancels this 7, leaving me with y. Straight across the top, 1 times 1 is 1. Straight across the bottom, 7 times 1 is 21. So y equals 1/21. Number 2, if I get negative 20/27c equals 4/9. I'm going to rewrite this underneath because it's a whole lot easier to work with if my number in the problem is not in the way. To solve this, I'm going to multiply by the reciprocal. I'm going to multiply by 27 over negative 20. Or I can multiply by negative 27 over 20. It doesn't matter where the negative sign is. If you do something to one side of the equation, you have to do exactly the same thing to the other side of the equation. Here, everything cancels out, leaving me with positive c. On the right-hand side of the equation, let's see, 4 goes into itself once, it goes into 25 times. 9 goes into itself once, it goes into negative 27, negative 3 times. Multiply across the top, I get negative 3. Multiply across the bottom, I get 5. So c equals negative 3/5. And of course, we can check these by putting negative 3/5 back into the original equation and seeing if I end up with the same answer. Let's check it a little bit here. If I have negative 20 over 27, and I multiply that by c, which is negative 3/5, what do I get? Well, 3 goes into itself once, 3 goes into 9 times, 5 goes into itself once, 4 times. I end up with negative 4 times negative 1 is positive 4. 9 times 1 is 9. I get 4/9. Exactly what that is, so the problem does check out. Number 3, 2y equals 7/9. So if I have 2y equals 7/9, I'm going to multiply by 1 over 2. It's the same thing as saying 2y over 1. If you do something to one side of the equation, you have to do the same thing to the other side of the equation. 2's cancel out, and y equals 7 times 1 is 7, and 9 times 2 is 18. So y equals 7/18. Number 4, 2/9t equals 5/6. To get t by itself, I'm going to multiply by 9/2. If I do something to one side, let's do exactly the same thing on the other side. On the left side of the equation, everything cancels out except for the t. On the right side of the equation, 3 goes into 6 twice, 3 goes into 9 3 times. 5 times 3 is 15. 2 times 2 is 4. And we can leave it as 15/4 because when you check it back in, you can leave it as an improper fraction. Or if you really want to, you can change it to a mixed number. So t here would be 3 and 3/4. I don't care when you get to multiplying and dividing equations, whether you leave them as an improper fraction or a mixed number. But to me, it's not really that critical because if you were to go check it back in, you'd have to put it back into the form of 15/4 to check it. Number 5, negative 7/20 equals 1 1/6 r. Well, here I have to change 1 1/6 into an improper fraction first. So I have negative 7/20 equals 7/6 r. So I have to multiply both sides of this equation by 6/7. These will all cancel, leaving me with r. Here, 7 goes into itself once. Let's see, 2 goes into 6 3 times, 2 goes into 20 10 times. So I'll end up with 3 times negative 1 is negative 3. 10 times 1 is 10. Don't lose your negative signs. I knew my negative sign was right there, and I didn't lose it somewhere in the problem. Number 6 here, we should change to improper fraction first. So negative 2 3/4 becomes negative 11 fourths h equals negative 12.5 is negative 25 halves. Multiply both sides of the equation by its reciprocal, which in this case would be negative 4 over 11. Okay, negative 10 there. Multiply by negative 4 over 11 here. Everything cancels out here, leaving me with h. On the right-hand side, 2 goes into negative 4 negative 2 times. So I get negative 50 over 11, which I could leave as negative 50 over 11. Or I could change that. Okay. Shouldn't be negative because I got 2 negative signs, a negative here and a negative there. So let me get rid of that negative sign. So it shouldn't be negative 50 over 11. It should just be 50 over 11. And if I change that to a mixed number, that would be 4. And that'd be 44. So that'd be 4 and 7/11. Well, 44 and 6/11. 44 and 6/11, not 7/11. Boy, I'm having a lot of trouble today. It's 50 minus 44 is 6, so 4 and 6/11. Last question, word problems. You solved a set of word problems exactly like you solved them for anything else. How many 2.5 ton trucks can you place on a rail car that has a carrying capacity of 15 tons? In other words, big giant rail car, moving, big giant train rail car is holding a whole bunch of trucks on it in each car. Each truck weighs 2.5 tons. The train car can hold 15 tons. So we need to figure out how many trucks can we fit on it. So if I let n equal the number of trucks, the weight of each truck times the number of trucks is what we call carrying capacity. Okay, so the weight of each truck is 2.5 tons times the number of trucks, which we don't know, so I'll let that equal n, equals the carrying capacity, which in this case is 15 tons. So our equation is 2.5n equals 15. So first of all, I have to change this to a mixed number, from a mixed number to an improper fraction. So that's 5 halves n equals 15. To solve for this, I'll multiply by the reciprocal, 2 over 5. Do that to one side, do it to the other side. Everything on the left-hand side of the equation cancels out. And on the right-hand side of the equation, 5 goes into itself once, it goes into 15 3 times. 3 times 2 is 6. So I can put 6 trucks on the rail car. So 6 trucks can fit on the rail car.